We have arrived AP Statistics in Unit 5. Yay for us! Okay, what is Unit 5? Well, Unit 5 consists of Chapter 16 and Chapter 17. So in Chapter 16, which is what we will be discussing in this video, we're going to talk about discrete random variables and their distributions. So let's fill in the blanks here, and I will explain as we go along. So a discrete random variable, x, has a countable number of possible outcomes. And what that means essentially is when I create a distribution for the value of x, all of my values are going to be countable, like 1, 2, 3, something like that. And it doesn't have to go in order. It can be 1, 5, 6, however many, whatever your outcomes are for whatever the situation is. So the thing you need to remember about discrete is that it's not a continuous distribution. A continuous distribution would take into account all of the little decimals in between 1 and 2 and 2 and 3 and 3 and 4. So we don't do that in discrete random variables. These are all going to be countable values. So the probability distribution of x is going to list the values. Those are going to be right up here, and their probabilities. And of course, that's going to be in this row right here. So please keep in mind that your probability in this table must satisfy the rules of probability. So what does that mean? Well, that means that none of your probabilities can be bigger than 1 or less than 0, and they all need to add to a total of 1 because those are all the possible probabilities. So let me just finish filling this out here for you. Okay, so when we look at a distribution for discrete random variables, we need to talk about the mean, and we use the Greek letter mu, that's what that is right there, to represent the mean, because it's not just an average, it's a weighted average, because it's going to take into account the idea that each of the outcomes is not equally likely. So it's not like a straight average where you're just taking the numbers and adding them and dividing by how many there are. This is a weighted average, like your weighted GPA. I know you all know what that is. Okay, so the mu is called the expected value. That's what we call it. And that does not mean we expect to get that value on any one trial. It means that we are going to expect that average in the long run after a lot of samples are taken. So keep that in mind. So that will come out again when we're looking at some more examples, etc., etc. Okay, so what if we have this discrete probability distribution right here, and this of course is just written in general terms of x and the probability of p sub 1, 2, etc., etc. So when we use a weighted average to find the mean, the equation for that actually looks like this, and it is on your formula chart. It looks a little scary, but essentially all it means is that we are summing all of the x values times their probabilities. So as a simple example, let's say I had something like this for a probability distribution, and all my possible outcomes were 1, 2, 3, and the probabilities were 0.6, 0.3, and 0.1. So let's say I take 1 times 0.6 plus 2 times 0.3 plus 3 times 0.1. And then, of course, I would multiply and then add, and then that would give me, oops, if I can add, 1.5. So when I add that together, Okay, that is going to give me my expected average. So for this particular situation, whatever X is, okay, whatever that represents, I can expect in the long run to, if I take many samples, to get an expected value of 1.5. So when you see the words expected value in your head, you need to be thinking, oh, that's a weighted average. So please keep that in mind as we move forward with this. Okay, so you can just find the weighted average by hand by doing that right there, or you can follow my directions that I have down here to use Staplet or to use a graphing calculator. And these instructions are for a TI-84. The TI-83 is a little different, but it should in general help you figure out what that is. Okay, so we need to talk about the variance of X. The variance of X is just the sum of the differences between all of your outcomes in the mean squared times the probability of each of these. Now, the variance is just basically the standard deviation squared, because the standard deviation is this symbol right here. That is little sigma from the Greek alphabet. So the standard deviation of X is the square root of the variance. What's the variance, Miss Griggs? Well, to be blunt and obvious, it's the standard deviation squared, just like it says. Why do we need it? Well, we need it for mathematical calculations in a later unit. So I want you to go ahead and familiarize yourself with the fact that variance means the standard deviation squared. All right, so of course both of these formulas are on your formula chart, and as we move through working through examples, all of this stuff will make a little bit more sense as we're moving through it. So please keep in mind a couple of things as I end this video. Remember that your expected value means that if I were to take many more samples, I would expect the average of whatever I'm measuring to be the expected value or the mean. Weighted mean. Okay, when I'm interpreting the standard deviation, remember from Unit 1 that the standard deviation tells me the typical distance from the mean. So how much variability seems typical on either side of the mean. So that is what we're talking about when we're talking about standard deviation. That's just to remind you of how we interpret things. So hopefully this was a good intro video for you to discrete random probabilities. Now we're going to do some examples. Yeah, baby.